Okay, everyone, we'll move to motivation, which I kind of felt, way more easier than the other topic in this module. So motivation, it talks about, three things. So the convolution helps because of three more. So to deal with convolution, we need three things. That is sparse interaction, parameter sharing, and equivalence of, translation. So it's very simple thing. See, convolution leverages three important ideas to improve machine learning system. These are paradoxy, sparse interactions is nothing but input and that output interaction, parameter sharing, and equivariant representation. Additionally, convolution provides means of working with variable size inputs. So I don't know whether you can see the textbook images which I am displaying right now. So just see here over the image of see, this is our input. You can see this, see A, B, and this. Wait, let me just try to highlight this. If I highlight A and B and E and F, and then I'll highlight W, X, Y, Z. So see, instead of whole image, it's focusing on a particular edge and then multiplying every element with it. So if you see here, A W, B is with X, P is with W. So like X is X, W, Y, Z. These are all multiplied by things. First you'll multiply as it is: A into W, B into X, E into Y, F into Z. So here in the next thing, you just change the letter, like shift one. So A will become now B, B will become C, E will become what? After E, what comes? F. After F, what comes? G. See, same thing. So one by one, like that, you just have to draw. What it says here, an example of 2D convolution without kernel flipping. We restrict the output to only positions with the kernel lies entirely within the image, called valid convolution. In some context, we draw boxes with arrows to indicate how the upper left element of the output tensor. As if we don't want this crap, we just have to understand that okay, we are focusing on one part. So whatever the kernel is, however the kernel is pointing towards, the input will or the output will go to that particular direction. So we'll see what is actually this sparse interaction. Normal fully connected layer. So every output. So in normal neural networks, so every output is connected to every input. So too many connections means too many parameters and too much to compute. But what happens in CNN? So kernel is small, like 3 cross 3 matrix or 5 cross 5. We also saw 2 cross 2. So each output looks at only a small local region. So each output depends only on k inputs. K is small, as you saw in the image. So see, only 4k here, k like 4 values are there. Similarly, if you see in this image, so here we have two things. When S is formed, so here if the kernel width is 3, value is 3, so it will be pointing towards 3 outputs itself. But if it is interconnected, where the output is formed by matrix multiplication, then every input will be pointing or connected towards the every output. That's what they are trying to say over here. So in CNN, kernel is more like 3 cross 3 of a matrix. Each output looks at only a small region, local region. So each output depends on k inputs. The result: fewer parameters, fewer computation, better statistical efficiency. So then you have to see here, dense layer params are nothing but m into n. So basically, like too many layers are there, m into n. So m will be a very big number. But in convolution, that is sparse connectivity, params are like k into n, where k is very very small. So this meaning is k less than m, so it is less than m. It can be very close, little number, like less than m, in the sense k. If m is 10, then k might be 5, 1 to 5, or like that with that thing. But if you are putting too many times, so see, this is good. So see, this is like the example like that. That's exactly what figure 9.1, 9.3 are showing. So see here, we saw the 9.2 when k is only 3 here, then matrix multiplication like that. And also see here, many multiple inputs pointing towards one single output, or when it is specifically defined, then only 3 are pointing towards it. It's just all about that. Okay, so in figure 9.4, in deeper layers, receptive field grows. Even though each layer is locally connected, multiple layers make a neuron indirectly see a large part of the image. So CNN still capture global relationship, but efficiently. So here you just see the example here, like deep layers. So here somehow see every input is not connected to this H or HI layers. HI in the sense of 1, 2, 3, 4, 5. It's not connected to them, but they are connected to one or two, and then ultimately they are connected. So basically, if you see at G, so all the inputs are connected to this. In a way, if you just try to look at it in that way, so it is like that. Then you have the parameter sharing. It's very simple thing. So in normal dense network, each weight is used once, but in CNN, some kernels weights are reused at every special location. One filter scans the whole image. So instead of instead of learning separate edge detector for top left or bottom right, CNN learns one edge detector and use everywhere. Results huge reduction memory, improve our generation. So we'll understand with that image over here. As you can see here, this image in 9.5, the top image here, you see every input is connected to the output over here. So you can see some parameter sharing. So here what happens, for every input the same parameter is used again and again. Okay, but here if you see only one is connected, directly connected. So here partially connected. So here what happens, the what to say, parameter is used only once. That's what they are trying to say. If you just read this, you'll understand that. I have to erase that. I don't want that. Going back. So translation equivariance, it's simple, very simple. So you have to remember this. See, f. Okay, so I have g of x. Okay, then f of something, that is f of g of x is equals to g of something. What is that? That something, f of x. Simple. So whatever is happening in the current input, that should be displayed in the output. The what it say, if you shift the input, the output shifts in the same way. Okay, so what in the meaning, if G shifts the input image right by 1 pixel, then the feature map also shifts right by 1 pixel. For example, at present time, if something change, that will be reflected in the output later. So if something is going to change the input later, that will be reflected in the output later. So CNN doesn't break when object moves. It produces the same detection patterns, just move. Something, if there is a movement, it shows that in the output. That's how convolution is powerful for image and time series. Event later in time detected later in output. So whatever the happening in the present time, it is detected in the output layer. So object moved in image detects a new location in the output. Here is the some extra notes which you can study for yourself. This is the overview of the complete two sections, that is convolution and motivation. We'll see in the next video, like covering pooling. Okay, so pooling, and we'll cover this convolution and pooling as infinitely strong prior. We'll see that, and we'll also move in one video where we'll cover this entire thing. So far, let's see is again let me tell about the AI which I have been using. See, it's not like a promotion, it's just like, I want you to use this so that sometime if you find some doubts or something, you can just use this AI to uh, get clarification. The free trial won't have 5 grades only for lifetime. So you can see that some pro applications, like where that you have this image or generation, or like grok API, or that gamma, where you generate slides and all. They give you temporary credits only. If you share to someone, you get only 1 credit, but to use it often, you'll be creating multiple emails and but it's all waste. So if you have 300-400 per month, so if you have to multiply it by 12, so 40, and then 4,800 is the actual cost, if you go monthly. So if you go years back, then 333 per month. So bill is 3990 instead of 4,880. So it's, you are actually saving. Then pro feature is 666. So it's, you have multiple. So every month you'll be having 100 grades. Here every month 50 grades. So it's very helpful for you to use this AI thing. It has so many features. See all the 9 features which are actually working, readily working. Anyways, it's your call, bro, but it's very useful.